So the graph of negative, oops daisies, negative f of x is the graph of f of x, so whatever that original graph or that original parent function is, and it's been vertically reflected in the x-axis, upside down. Okay, so here we've got a question that's like, here you've been given this graph, the f of x, and it looks, there's our graph of f of x, a little step down weird line thing. We have to graph the negative of the original function. So we have to vertically reflect it. And a nice thing to do when you're doing invariant points, that's what they're called. Invariant points are points that are unaltered by a transformation and they ended up repeated. So if I look at this point right here, no, I'll make it black. This is -3 at +2. When we invert this, our y value is going to go from being a positive value to a negative value. So our new one is green, is going to be -3, but then at -2. So this point gets reflected down there, right down here. So let's look at this point. This is 0 at -1. Our y value, because we're vertically changing this, is going to become negative. So it'll stay as a point at 0, but we're now going to become +1. 0, +1. This is -3, -2. Then let's look at this one. We've got 4 at 1. Our y value, because it's vertical is up and down, affects the y. This is going to be affected. It's going to become 4, -1, right there. And our last point down here, which is 6 at -3. Vertical reflection is going to affect our y value, not our x value. Vertical only hits the y's. And it's going to make it change signs. So if it's -3, it's going to become +3. 1, 2, 3. Boom. This is 6 now at 3. So we're going to take some lines, because you fake it till you make it. Okay. Yes, I want that color. That goes there. That goes there. That goes there. Boom! I have taken that original function and I have flipped it upside down, and now if I want my full marks, because I like full marks, I am actually going to say y is -f of x, because that's what we did. We made the original function and we flipped it vertically.